It's a remarkable yet factual story that you have a stellar origin. The very atoms that constitute your body were forged in the cores of suns that exploded billions of years ago. Every breath you draw and every beat of your heart carries the echo of distant supernovae. This journey will explore the cosmic pathways this stardust traveled to form oceans, mountains, and ultimately you, a story of death, transformation, and rebirth that links us all to the deepest corners of the universe.
What if I were to tell you that every atom of carbon in your cells and every molecule of oxygen in the air can be traced back to the cataclysmic deaths of stars that lived eons ago? This concept might seem astounding, but it is a fundamental truth that intimately binds us to the cosmos. While stardust itself is composed of particles too small for the naked eye to see, it is the direct result of colossal processes unfolding across the galaxy, making it a profound link between you and the stars. Throughout cosmic history, stars have functioned as the great architects of matter. You can envision a star as a celestial factory, where the phenomenal process of thermonuclear fusion transforms simple elements into the more complex components of our universe. But what becomes of these elements once a star depletes its fuel? It ends its life in a supernova, a titanic explosion that ranks among the most spectacular events in the cosmos, releasing immense quantities of energy and newly created material into the void. It is during these cataclysmic events that stardust is dispersed, enriching the interstellar medium and providing the raw materials for new generations of stars and planets. This dust doesn't merely drift, it enters an endless cycle of creation, traveling across the cosmos before integrating into new stellar formations and planetary systems. If you have ever wondered how planets take shape around a star, it is thanks to this very dust, which accumulates and compacts to give rise to worlds just like our own. The chemical makeup of stardust is another vital piece of this cosmic narrative. Composed of essential elements like carbon, oxygen, and nitrogen, this dust is not only crucial for the formation of stars and planets, but also plays a key role in creating the complex molecules necessary for life. Had it not been for this stellar inheritance, Earth would never have become the fertile and vibrant world we inhabit today. Here on Earth, stardust has influenced the course of evolution from the very beginning. Every grain that settles on our planet serves as a reminder that life is not an isolated phenomenon, but rather the result of a long succession of cosmic events. Our planet's history is inextricably woven into the history of the universe. When you consider the air you breathe, or the atoms within your cells, you can almost feel the pulse of the cosmos within you. A connection that makes us all part of a single, magnificent, cosmic web. This same principle underpins the search for life on other planets. Scientists are now beginning to grasp that the necessary conditions for life might exist in places once considered completely inhospitable. Astrobiology delves into this fascinating possibility, exploring whether the very stardust that shaped our world could also be the key to unlocking the existence of life beyond Earth, potentially seeding other worlds with the building blocks of biology. Observing stardust is a significant challenge for astronomers, who rely on powerful telescopes and space probes to study this elusive material. These instruments enable them to capture light that has passed through clouds of dust, which reveals critical information about its chemical composition and its distribution throughout space. It's a method that allows us to understand what lies thousands of light years away, simply by analyzing how stardust interacts with light. The history of stardust is, in essence, the history of the universe itself. From its origins in the aftermath of the Big Bang to its constant dispersal through the death of stars, this dust has been a central player in the evolution of the cosmos. Studying it helps us comprehend how the grand structure of the universe formed and has changed over billions of years, prompting us to reflect on our own place in this cosmic story and the legacy we might leave behind. Beyond science, Stardust has also secured a place in human culture. Throughout history, countless civilizations have interpreted the stars and cosmic dust in unique ways, creating mythologies and philosophies that reflect our intrinsic connection to the universe. These beliefs, both ancient and modern, continue to shape our understanding of the cosmos and our place within its vastness. As we look to the future, Stardust will continue to be a subject of intense research and profound wonder. Questions regarding its origin, its role in birthing new stars and planets, and its influence on life here on Earth will persist in intriguing scientists and philosophers alike. Stardust is far more than a simple cosmic element. It stands as a constant reminder that everything we know has been shaped by the immense forces of the universe. In the end, our existence can be viewed as a fleeting spark in an ever-expanding cosmos, a realization that is both humbling and inspiring. Stardust is the fascinating concept that connects us so deeply to everything around us. To define it simply, it consists of tiny particles floating in space, composed of elements like carbon, silicon, oxygen, and heavy metals, all of which are the products of the extraordinary life cycle of stars. To truly comprehend the origins of stars, it helps to think of them as magnificent celestial factories. Throughout their extraordinary life cycles, which span millions of years, they continuously forge new elements within their cores. Their story begins within a nebula, an immense cloud of gas and dust where gravity slowly draws particles together, causing them to heat up and condense into a dense, glowing protostar. Once this protostar achieves extreme temperatures at its core, it ignites, transforming from a simple collection of matter into a newly formed star. The journey that follows is anything but uniform. A star's mass is the critical factor that determines its entire life path. It could evolve into a dwarf star much like our own sun, or, if it is massive enough, it is destined for a far more dramatic existence and a spectacular end. Smaller stars conclude their lives by expanding into red giants before gently shedding their outer layers into the surrounding space. Their core then collapses under its own gravity, leaving behind a dense remnant known as a white dwarf. In stark contrast, the end for massive stars is an incredibly violent event. A supernova explosion so powerful it can briefly outshine its entire home galaxy, releasing a colossal amount of energy and matter. This cataclysmic explosion is not just an ending but also a crucial act of creation, serving as a generator for cosmic dust. At the moment of its death, the star expels all the heavier elements it has forged, scattering them across the vastness of the universe. This ejected material, known as stardust, becomes the fundamental building block for the next generation of celestial bodies, providing the raw ingredients for new stars and planets. This cosmic dust eventually mixes into molecular clouds, which act as stellar nurseries where matter can clump together once more. The composition of this stardust is particularly fascinating because it contains elements absolutely essential for life as we understand it. In fact, you should know that the carbon, oxygen, and other elements that make up your own body were originally created inside a star and delivered to Earth as part of this cosmic cycle. Stardust is not only vital for the formation of new planetary systems, but also profoundly influences the chemistry of those nascent worlds. When a planet forms, It is built from the very same dust that created its parent star, a reminder that we are intrinsically connected to the cosmos. Scientists have even discovered that this dust can affect a planet's climate by influencing cloud formation and precipitation, linking us to space in ways we are only just beginning to grasp. Research into stardust is a constantly evolving field, with astronomers using powerful telescopes and space probes to study these particles in greater detail. Each new discovery helps us better understand their formation, their interactions, and their indispensable role in the evolution of the universe. The secrets of our own existence are continually being uncovered through the study of this seemingly simple dust. So, the next time you gaze up at the night sky, remember that you are looking at more than just twinkling points of light. You are witnessing the legacy of ancient stars that have left their imprint on everything, including you. In this immense cosmic tapestry, stardust is the thread that weaves our story together, a narrative that continues to unfold in every corner of the universe. This entire process is essential for the universe's evolution and the birth of new celestial generations. But what factors decide the kind of star that will emerge from a given nebula? The answer lies in the quantity of matter within the original cloud. Stars with greater mass evolve rapidly and have much shorter lifespans, whereas smaller stars, such as dwarfs, can radiate light for billions upon billions of years. Every star is set on its own path, and each of these individual fates is intricately woven into the immense cosmic tapestry. As stars are born and later perish, the resulting stardust becomes a vital ingredient of the cosmos. This dust is more than just a beautiful spectacle. It serves as the very bedrock of everything we know, as life-critical elements like carbon and oxygen are forged within the cores of stars. When a star violently explodes, these fundamental elements are propelled out into space, ready to be incorporated into new stellar formations. It's truly incredible to consider that the dust you might find in your home has a lineage that traces directly back to the stars. Each particle has journeyed across space and time, participating in a cosmic cycle that unites us with everything in existence. How can we be certain this cycle is not just a theory? Through detailed astronomical observation, scientists have successfully traced this dust and mapped its evolution across billions of years. Stars, for all their magnificence, are not immortal. Their lives are characterized by constant change and transformation, and in the end, they must yield to their destiny. Though their legacy endures in the stardust that creates new stars, planets, and eventually, life itself. This cycle of stellar life serves as a powerful reminder that an end can also signify a new beginning. The narrative of the stars mirrors our own existence in numerous ways. Just as they undergo transformation and evolution, so do we. We are linked to the universe through the very elements that compose us, a connection that becomes even more profound when you realize you are part of a much larger cosmic pattern. Within every part of your being, you carry a piece of the universe, an echo of stars that once blazed brightly in the heavens. Ultimately, a star's life is an epic saga that encourages us to contemplate our own position in this boundless cosmos. Every star is a guide, teaching us about transformation, connection, and the persistence of life. And while their time may be short, their impact resonates through eternity, reminding you that we are all composed of stardust. Supernovae represent breathtaking and momentous events within the life cycle of a star. But what precisely is a supernova, and what makes it so indispensable for the creation of stardust? To grasp this, you must first examine the ultimate fate of stars. When a truly massive star depletes its nuclear fuel,
its core implodes under its own gravity, setting off an immense explosion that is both a spectacular cosmic light show and the main factory for stardust.
Picture yourself at a rock concert, where the band is playing its final number and the atmosphere is electric. At the song's climax, the lead singer throws their guitar high into the air, and it smashes into countless fragments as it hits the stage. A supernova functions similarly, scattering its outer layers, which are rich in chemical elements, across the vastness of interstellar space. These elements are much more than simple particles. They are the fundamental components of everything from planets to living organisms. Supernovae do more than just generate dust. They enrich the interstellar medium with heavy elements like carbon, oxygen, and iron. Have you ever paused to think about the origins of the elements that constitute your own body? The answer is found in the life cycle of stars, and specifically in these supernova events. Each time a star detonates, it sows the seeds of life across the cosmos. The stardust created in these explosions drifts through space, gathering into clouds of gas and dust that ultimately collapse to form new stars and planets. This naturally raises a fascinating question. Can stardust be considered a kind of cosmic fertilizer? In many ways, the answer is yes, as it provides the essential nutrients for the next generation of celestial objects. Following a supernova, the process of stardust formation is nothing short of extraordinary. The explosion generates extreme temperatures and pressures, compelling atoms to fuse in new configurations and create dust particles that can vary in size from a grain of sand to a small moon. Isn't it mind-boggling to think that the same elements making up your body were once part of a star that exploded somewhere in space? Not all supernovae are identical. Different types exist, each with unique characteristics and contributions to the stardust supply. For instance, Type 1a supernovae occur when a white dwarf siphons material from a companion star until it reaches a critical mass and explodes. In contrast, Type 2 supernovae happen when a single massive star runs out of fuel and collapses. Can you envision how different the stardust from these two explosion types might be? The scattering of stardust is not a one-time occurrence, but a continuous process that fuels the life cycle of the universe. As this dust spreads, it combines with other clouds of gas and dust, giving rise to a new generation of stars. This is the mechanism by which the universe endlessly recycles itself in a perpetual cycle of creation and destruction. It's remarkable to realize that any star you see in the night sky might be the product of a supernova that happened thousands or even millions of years ago. Stardust is pivotal in the formation of entire galaxies. As vast quantities of dust and gas accumulate and condense, they can ignite new stars, which in turn can foster planetary systems. This brings us to another compelling idea. Could supernovae be considered the architects of the universe? In a very real sense, they are. Without their explosive contributions, our cosmos would be an entirely different and far emptier place. Stardust also plays a key role in cooling interstellar regions and enabling the formation of complex molecules in space. As cosmic dust begins to coalesce, it gathers more matter and builds increasingly massive formations. These cosmic structures not only set the stage for future stars and planets, but might also harbor the very building blocks of life. This prompts a fundamental question. Could stardust truly be the origin of all life in the cosmos? To investigate supernovae and the dust they produce, astronomers employ a range of techniques, including multi-wavelength telescopes and deep space probes venturing through our solar system. Researchers are perpetually searching for new approaches to grasp how these cataclysmic events shape the universe. Just think about a future where we could forecast the timing of a supernova and anticipate its precise effects on our corner of the galaxy. In this quest for knowledge, scientists have found that stardust does more than just build new stars and planets. It also plays a role in shaping a planet's climate and the chemistry of its atmosphere. So the next time you gaze at the night sky, I encourage you to see those stars not as mere specks of light, but as colossal factories churning out the very dust that has been essential in forging the universe we inhabit. The path of stardust is an epic and captivating journey, beginning with its violent birth in a supernova and culminating in its integration into new celestial bodies. What's truly remarkable is the perpetual nature of this cycle, where every stellar explosion presents a fresh chance for stardust to create something entirely new. How this ongoing process will reshape our cosmic perspective remains to be seen, but it reminds us that every star you see tells a profound story, one that starts in its core and concludes with the birth of dust that could one day form new worlds, and maybe even us. This material, which we call stardust, drifts through the immense void of space, and its journey is an extraordinary tale connecting stellar life and death. The story begins when a star depletes its fuel, triggering a spectacular final explosion known as a supernova. This brilliant event isn't just a light show, it's the very forge for stardust, launching a grand cycle of transformation. The resulting particles act like cosmic seeds, traveling across unimaginable distances and carrying the essential chemical elements forged inside the parent star, the very carbon and oxygen atoms that will later form new celestial bodies. So, how does this cosmic dust assemble into new structures? Over eons, it accumulates into vast, dense clouds known as nebulae, where gravity begins to take command. In a kind of cosmic ballet, particles pull toward one another, creating progressively larger clumps that are the precursors to new stars and planets. Any dust left over from this process continues its journey, enriching the interstellar medium like a cosmic fertilizer and delivering the necessary ingredients for life to potentially arise in other parts of the universe. Once new stars ignite, their powerful radiation and stellar winds begin to sculpt the remaining dust, creating new formations and clouds. This dust, now orbiting the young star in massive rings, serves as the raw material for planets in a construction process that spans millions of years. This directly connects to our own existence here on Earth, as the history of stardust is woven into the history of every planet. The very elements vital for our survival, the carbon in your body and the oxygen in the air you breathe, originated inside these long-dead stars, a poetic reminder of our shared cosmic heritage. This cosmic cycle doesn't stop with planetary formation. Planets themselves can eject dust back into space through volcanic eruptions or cataclysmic impacts, where it might be captured by other systems to begin the process anew. Furthermore, the harsh environment of space, with its extreme temperatures and intense cosmic radiation, constantly alters these dust particles, changing their properties and influencing the future systems they will help create. Ultimately, the story of stardust perfectly illustrates the universe's cyclical nature. A star's death is never a final act, but rather the very beginning of the next chapter of cosmic creation. Every speck of cosmic dust serves as a link between the universe's past, its present, and its future. So, when you next gaze upon the stars, consider that the dust adrift in space is undertaking a monumental voyage. This journey doesn't just sculpt the cosmos, it also binds every one of us to the sagas of the stars that illuminate the night, drawing us into an eternal cycle of creation, destruction, and renewal that beckons us to discover our place in the grand expanse.
So, what is it that makes Stardust so captivating? The answer transports us to a realm where chemistry reads like cosmic poetry. For these minute particles are far more than simple debris. You should think of stardust as the inheritance left behind by stars. When a star exhausts its life, it erupts in a cataclysmic event called a supernova, which blasts not only energy but also a rich blend of elements across the cosmos. Consequently, the material we call stardust is a composite of carbon, oxygen, silicon, and other fundamental elements that form the very foundation of all known matter. Have you ever considered the process by which these basic elements evolve into something more profound? As a cosmic traveler on a journey spanning millions of years, stardust is subjected to the severe conditions of space, where cosmic radiation, frigid temperatures, and gravitational pulls dictate its behavior. Within the deep chill of molecular clouds, these conditions allow atoms to bond into molecules. This is a critical step in forging the compounds that ultimately provide the groundwork for life, such as complex organic molecules like amino acids. This makes stardust a central player in prebiotic chemistry, the very sequence of events that set the stage for life to arise on Earth. It's important to realize that stardust is not a single, uniform substance. It is incredibly diverse. Different grains possess unique chemical makeups, with some being rich in carbon, while others are composed of silicates or heavy metals. This variety is crucial, as it provides the raw materials for creating planetary systems, and also allows stardust to act as a cosmic thermostat. By absorbing and scattering light, dust directly influences the temperature of molecular clouds, which can determine whether a cloud ignites with new stars or remains dormant. This interaction with starlight also turns dust clouds into a kind of open book for astronomers, as the scattered light reveals the dust's chemical signature, telling the story of its cosmic neighborhood from light years away. The behavior of stardust also changes dramatically depending on its environment. In certain regions, it gathers into dense clusters that serve as nurseries for newborn stars, while in others, it scatters widely to enrich the interstellar medium with fresh elements. Much like ingredients in a recipe, combining to create a final dish, this dust is a pivotal component in the formation of planetary systems. Through a cosmic dance of accumulation and condensation, these particles compact into the larger bodies that grow into planets, meaning that even the most commonplace objects around you are ultimately composed of ancient stardust. But what is the impact of stardust on life itself? The very elements it carries, carbon, oxygen, and nitrogen, are the indispensable components of our DNA and the molecules that constitute all living things. Without the raw material of stardust, there would be no organic matter, and consequently, no life as we know it. This brings us to a remarkable realization. With every breath you take and every object you touch, you are fundamentally interacting with the remnants of ancient stars. The significance of stardust is amplified within the field of astrobiology. Scientists believe that dust found on other planets and moons, both in our solar system and beyond, holds the key to the search for extraterrestrial life. Analyzing the chemical makeup of this distant dust could offer vital clues about whether conditions suitable for life exist elsewhere, making it a primary target for scientific inquiry. In the end, stardust serves as a powerful symbol of our universal connection, a reminder that we exist within a far grander cycle. What may appear to be mere cosmic refuse is, in reality, the substance that forged our world and from which we are constructed. So, the next time you look up at the night sky, remember that you are not just seeing distant suns. You are looking at your own cosmic origins and acknowledging that in the most literal sense, we are all made of stardust.
Stardust is a mysterious substance drifting through the limitless universe, and it has played a critical role in the creation of our home, Earth. But how is it that what appears to be simple cosmic debris is so essential for our very existence? On this cosmic journey, we're going to explore the deep connection between stardust and the history of our planet. To start, picture the Earth as a massive sphere of ingredients. Much like a chef requires specific components for a great recipe, our world needed a precise combination of materials to come into being. Stardust, acting as a sort of cosmic chef, delivered these vital elements. But where does this incredible dust originate? Its story begins with the death of stars, those giant spheres of gas you see in the night sky. When a star depletes its fuel, it erupts in a massive explosion called a supernova, a spectacular event that releases chemical elements out into space. This process is how stardust scatters throughout the cosmos, enriching the interstellar medium with the materials that will eventually give rise to new stars, planets, and even life itself. To truly grasp this relationship, you need to understand how our solar system was born. Around 4.5 billion years ago, a vast cloud of gas and stardust started to collapse under its own gravitational pull, a natural process that ignited the sun and formed the planets orbiting it. So, in a sequence of events that sounds like science fiction, stardust served as the fundamental raw material for our entire world. So, what exactly makes up this stardust? It is a complex mixture of elements, including carbon, oxygen, nitrogen, and many others. This dust isn't just a remnant. It's the foundational substance poised to become something entirely new and remarkable. You can think of it as the collection of bricks for a new building. Without them, you simply couldn't construct anything. In this way, stardust becomes the indispensable ingredient for forging new stars and their planetary systems. Have you ever wondered about the formation of those vast gas and dust disks seen in astronomical images? These disks, resembling the rings of a planet, are not merely decorative. They are the active construction sites where the magic of creation unfolds. Here, gravity takes center stage, acting like a magnet that draws gas and dust particles together into a swirling, rotating disk where planets, moons, and other celestial bodies will eventually emerge. This cosmic construction project can take millions of years, and the stardust within these disks is far from uniform. It contains a wide spectrum of sizes and compositions, with each particle carrying its own unique history. Some particles are minuscule and almost unnoticeable, while others are large and dense. This elemental diversity is absolutely critical because each type contributes different properties to the new planetary systems, much like how every fruit in a salad adds its own distinct flavor and texture to create a rich and complex whole. When we talk about the formation of planetary systems, we have to acknowledge the immense timescale involved. A new world is not built in a day. In fact, the process can span hundreds of thousands of years. The reason for this slow pace lies in the way dust particles interact, constantly colliding, merging, and sometimes shattering apart. This intricate cosmic dance of collision and combination is what gradually builds worlds. As the dust begins to cluster, it forms solid cores that attract even more material. A pivotal moment in the birth of a new planet. You can compare it to making a snowman. You begin with a small snowball that gathers more snow as it rolls, eventually growing into something substantial. Once these cores become sufficiently large, we call them planetesimals, which are essentially the building blocks of planets. After these planetesimals appear, their gravitational pull becomes significantly stronger. They don't just attract more dust and gas, they also begin pulling in other planetesimals. This creates a runaway effect, like a snowball racing down a hill, accumulating more mass the larger it gets. This is how a planet is ultimately born, though not every planetesimal will achieve this status. Many will remain as asteroids or comets, destined to follow their own distinct orbits.
The development of a planetary system is a highly varied process. One planet might form relatively quickly, while another could take millions of years longer, because the conditions across the dust disk are never perfectly consistent. The amount of available material can differ from one region to another, and planets can even influence each other's growth, altering their orbits and trajectories. It's a grand game of cosmic dominoes, where every piece must fall into place for the system to function. This entire complex history brings us to Earth. Our own planet is the magnificent outcome of this long saga of stardust. Every part of our world, from the sprawling cities to the deep oceans, is infused with the legacy of this ancient dust. Without it, our existence would be impossible. So the next time you gaze up at the night sky, remember that this seemingly insignificant material was the architect of everything we know. The link between stardust and life doesn't stop at planet formation. Once these celestial bodies are stable, dust continues to play a role by helping create the conditions necessary for life to emerge. The elements delivered by this dust, carbon, oxygen, and nitrogen, become the essential components of the organic molecules that form the basis of all life. In the end, the story of how planetary systems form is a captivating tale of how stardust, in its countless forms, becomes the founder of entire worlds, from crafting planets to laying the groundwork for life itself. Stardust is the invisible thread connecting the vastness of the cosmos to the place we call home. When you look up at the stars, remember that they, and the dust that surrounds them, are an integral part of our own story. In a very real sense, you and I are also made of stardust. Think of these elemental particles as the letters in a cosmic alphabet, which combine to create the molecules that life requires. In the absence of this dust, you would have neither water nor air, and consequently, no life at all. The odyssey of stardust, however, doesn't conclude once it becomes part of a planet. As Earth began to coalesce, this cosmic dust was a constant influence on its development. The collisions of these particles and dust clouds in space were instrumental in forming our oceans and atmosphere. Essentially, stardust acted as the architect that engineered the very conditions for life's emergence. It's an incredible thought that with every breath you take, you are inhaling atoms that have journeyed across the cosmos for billions of years, connecting each breath to a deep cosmic history that started within the heart of a star. What about life itself? The core elements that constitute your body, including carbon and oxygen, have their origins in this very stardust. This means that, in a very real way, we are the descendants of these tremendous stellar explosions. Every individual, every plant, and every creature is a physical manifestation of dust that once drifted through the vastness of space, forging a profound and astonishing link that unites you with everything in your world. As you explore our planet and uncover its past, you also come to understand just how fragile we are. The specific circumstances that permitted life to flourish are both unique and delicate. Stardust, which might seem like a simple component of our reality, serves as a powerful reminder that all things are interconnected, and that the same cosmic forces that create and annihilate are also the ones that sculpt our home.
Science has achieved remarkable breakthroughs in comprehending this link between stardust and life here on Earth. Ongoing research continues to unveil new facets of how these cosmic elements have shaped the chemistry and biology of our world. Each new finding is like unlocking a doorway to an entirely new universe of understanding, placing stardust at the very heart of our search for answers about our existence. It stands as a potent symbol of the deep interconnection between the universe and life, a constant reminder that you are part of a much grander narrative. From the distant stars that glitter in the night sky to the very molecules that assemble your body, stardust is the common thread that weaves everything together into the magnificent tapestry of the cosmos. So, the next time you gaze up at the stars, remember that each twinkle is a testament to the dust that, over eons, helped shape our planet and the life upon it. It is truly extraordinary to realize that you are made of stardust. As we continue our exploration of the universe, it's vital that we never lose sight of this fundamental connection that binds us all together. Stardust is, quite literally, the material from which you are forged. But how is it possible that elements like carbon, oxygen, and nitrogen, so essential for life, originate from a place as remote and enigmatic as the cosmos? The answer is found within the captivating story of stardust and its direct relationship with biology on Earth. From the atoms that make up your body to the molecules composing the air you breathe, everything can be traced back to the dust forged inside stars. One of the most compelling questions is why carbon is so fundamental. This element, present in every living organism, provides the very foundation for life. But where does it come from? As stars burn, they fuse hydrogen into helium within their cores. However, at the end of their lives, during a cataclysmic explosion, they create an array of heavier elements, including carbon. This newly formed carbon is then scattered across space, eventually becoming part of new star systems and planets, including our own Earth. In this sense, every one of us is truly a child of the stars. Oxygen, the second most abundant element in your body, also has a stellar origin. During the final phases of their existence, massive stars generate oxygen through nuclear reactions. Following a supernova explosion, this oxygen is propelled into the void, where it can be incorporated into newly forming celestial bodies. It's amazing to consider that the very air you depend on was created in the core of a faraway star. Nitrogen, another indispensable element, shares this celestial history. Although its formation is a bit more intricate, nitrogen is produced during the lifespan of stars and is dispersed when their life cycles conclude. This element is absolutely critical for creating the proteins and nucleic acids that are the very building blocks of life. Without nitrogen, you simply could not exist. And what of the minerals and other trace elements that are equally important for life? They too have their own cosmic journey. During supernova explosions, elements like iron, calcium, and phosphorus are synthesized. These materials, just like carbon and oxygen, are integrated into the stardust. When this dust eventually clumps together to form new planets, it delivers a diverse mix of the elements necessary for life. The bond between stardust and biology doesn't stop with just the basic elements. Even complex molecules, such as those that constitute DNA and proteins, have their beginnings in this cosmic dust. When stars die, they release not only atoms, but also compounds that can combine into more elaborate structures, laying the groundwork for the chemistry of life. The influence of stardust is an ongoing process. As this dust permeates space, it can also affect the atmospheres of planets. Here on Earth, for instance, Stardust can act as condensation nuclei, which are essential for the formation of clouds. This means cosmic dust is not only a prerequisite for life, but also a key player in our planet's climate and water cycles. Furthermore, stardust carried to Earth on the solar wind can have a direct effect on the evolution of life itself. This influx can introduce new elements and compounds that may steer the development of different life forms. Researchers have discovered that certain minerals transported by this dust can be crucial for biological activity in the most extreme environments, prompting many scientists to ponder a fascinating question. What other kinds of life might exist on other planets? All thanks to stardust. Have you ever looked out at the immense cosmos and contemplated whether life exists anywhere else? Discovering life on other worlds represents one of the most profound challenges for humankind, and a crucial component in this investigation may be stardust. It raises the question, how could something so microscopic and seemingly unimportant hold such a pivotal role in the search for life beyond Earth? Life as we understand it is built from elements like carbon, oxygen, nitrogen, and iron. What's incredible is that every one of these elements is forged inside stars. When a star reaches the end of its life, it detonates in a supernova, scattering enormous quantities of stardust throughout space. This dust, which might appear to be nothing more than celestial refuse, is actually laden with the foundational materials required for life. As our exploration of the universe deepens, we face the challenge of tracing stardust and understanding its link to living systems. Scientists are now analyzing the cosmic dust that journeys through our own solar system. Through this analysis, they can determine the elemental composition of our planet, as well as other celestial bodies, uncovering vital clues this dust holds about our very origins. Think about our own planet, a small outpost in the cosmos, teeming with life. Evidence suggests that comets and meteorites, rich with stardust, have impacted Earth throughout its history. It is theorized that these impacts delivered the organic compounds that served as the initial recipe for life, implying that life on Earth may have begun as a consequence of a long journey across the stars. The chemical makeup of stardust is truly captivating, with each grain holding a diverse array of elements and compounds. Certain of these substances can assemble into the complex molecules fundamental to biology. This leads scientists to search for these exact compounds on other worlds, such as Mars or Jupiter's moon Europa, where their discovery could indicate that conditions suitable for life might also be present. With every improvement in telescope technology, this cosmic quest grows more exciting. Astronomers are engineering innovative methods to spot stardust in distant solar systems. Just picture peering through a lens to witness a supernova's aftermath as it happens, aware that its debris might be planting the seeds of life on a faraway world. A truly thrilling prospect. The field of astrobiology, which merges the principles of biology and astronomy, is dedicated to answering these very questions. A central hypothesis among its scientists is that stardust is a critical factor in the emergence of life. If this cosmic dust indeed carries the fundamental components of organic matter, it suggests that life might not be an anomaly on Earth, but a phenomenon happening throughout the cosmos. Yet, the solution isn't quite so straightforward. The hunt for life elsewhere compels us to acknowledge the specific set of conditions necessary for it to flourish. While stardust can supply the essential elements, a suitable environment, such as a world with liquid water oceans or an oxygen-rich atmosphere, is also required. The presence of dust is merely one piece of a much larger cosmic puzzle. Fascination with stardust extends well beyond astrobiology. Researchers are realizing that this dust plays a crucial role in the development of entire galaxies and star systems. This is directly relevant to the potential for life, because as new stars are born from this material, they give rise to new planetary systems, each one presenting a fresh opportunity for life to emerge. In this quest for life, interdisciplinary teamwork is essential. Experts from astronomy, biology, chemistry, and physics are joining forces to investigate how stardust forms a common link between their respective areas of study. This collaborative effort is paving the way for new lines of inquiry and promises unexpected breakthroughs. The link between stardust and life also invites deep philosophical contemplation. If the very atoms constituting your body were forged inside a star, how does that shape your identity as a human being? This recognition that we are literally composed of star matter serves as a powerful reminder that our existence extends far beyond Earth, making us integral parts of the vast cosmos. As our cosmic exploration advances, stardust stands as an emblem of both hope and discovery. Every speck acts as a conduit to the past and a gateway to the future. Contained within each particle is the history of stars that have perished and the blueprint of worlds yet to be born, leaving us to wonder what new narratives our continued search will reveal. Investigating extraterrestrial life and the nature of stardust forces us to introspect about our own place in the universe. It brings us to the ultimate question: are we solitary beings, or do we belong to a boundless sea of life that stretches beyond what we can envision? The key may be hidden within the silent, drifting dust that permeates space, waiting for us to find it. From this perspective, stardust is not merely the building material for life, but also a possible signal that life exists elsewhere in the cosmos. The very chemistry and biology of everything living on our planet are intricately woven into the story of this cosmic dust. Each time you gaze up at the night sky, you are looking at a reminder of the incredible cosmic voyage that led to our existence. When you next draw a breath, consider that the very air entering your lungs began in a star. This profound link between stars, dust, and life shows that we belong to something far more immense than ourselves. Stardust serves as the unifying thread in this cosmic tapestry, connecting every living thing on Earth and affirming our shared origins. It ties us not just to our world, but to the boundless universe around us. So the next time you look at the stars, know that every glimmer is a direct link to life itself. Within this cosmic dust lies not just the universe's secrets, but the very core of our own being. Over the centuries, astronomers have devised many ways to view the heavens, but a significant challenge has always been how to observe something as minuscule and fleeting as stardust. The solution, born from remarkable human creativity, involves using advanced telescopes on the ground and in orbit. These instruments allow us to study this celestial material, unlocking insights into the cosmos and our fundamental connection to it. Among the most conventional instruments in astronomy are optical telescopes, which function by gathering the visible light emitted from stars and other cosmic bodies. The problem is that stardust is often too faint and spread out to be easily seen with these devices. To overcome this limitation, scientists turn to telescopes designed to detect other wavelengths, including infrared and microwave. These powerful tools can penetrate dense clouds of dust, giving us a clear view of how stars are born and how dust is scattered throughout galaxies. In this field, infrared technology has been nothing short of revolutionary. Think of a completely overcast day where the sun is obscured. With infrared vision, you could still perceive its heat through the clouds. This is precisely how infrared telescopes operate, detecting the signature glow from newborn stars and cosmic dust that would normally be invisible. This method has allowed us to venture into the densest nurseries of space, witnessing the formation of new stars and planets, as if we are looking behind a cosmic curtain. Of course, our view from the ground is not the only perspective we have. The study of stardust has advanced dramatically.
thanks to space-based observatories like the Hubble and James Webb telescopes. By operating outside Earth's distorting atmosphere, they capture light with exceptional clarity, delivering images of galaxies and dust clouds with unparalleled detail. The difference in quality is like contrasting a picture shot in perfectly clear weather with one taken in the middle of a heavy fog. To get an even closer look, scientists have dispatched space probes on dedicated missions. Spacecraft like the Stardust probe have journeyed to comets and asteroids specifically to gather samples of cosmic particles. You can think of it like dragging a fine mesh net through deep space to capture and analyze its microscopic inhabitants. These probes bring back tiny fragments that narrate the history of our solar system, leading to incredible discoveries, such as finding materials within this dust that are even older than our own sun, giving us a direct glimpse into the universe's primordial era.
Another indispensable technique for astronomers is spectroscopy. This method involves separating the light from stars and dust into its constituent wavelengths, much like a prism creates a rainbow. Because every chemical element leaves a distinct signature within this spectrum, scientists can precisely determine the composition and origin of the stardust they observe. It's akin to hearing a complex piece of music and being able to identify each individual instrument by its unique sound, allowing us to understand what elements the dust contains and how they came to be. The photographs we capture of stardust are often breathtaking, showing vast clouds of vibrant color and fluid, irregular forms that appear to drift through space. Beyond their sheer beauty, these images are rich with stories. Each nebula might be a stellar nursery, giving rise to new suns, or the final remnants of a dying star, scattering its essence into the void. Can you picture yourself as an explorer, navigating the stellar ocean, floating through these spectacular, colorful formations? With every improvement in our observational techniques, we draw nearer to comprehending the immense web of stardust that constitutes the very fabric of our universe. Each individual speck carries its own history, and by studying them, we decode secrets that have been locked away for eons. The significance of this material to our cosmic knowledge is immense, as it is key to understanding not only how stars and planets are born, but also the grand evolutionary story of the cosmos itself. Every technological leap forward unlocks incredible new findings, which in turn spark even more profound questions. Stardust serves as more than just a basic building block of the universe. It is a constant reminder of our deep connection to everything out there. When you look up at the night sky, you are seeing the outcome of billions of years of cosmic history, and that dust is a character in its narrative. So the next time you find yourself looking at the stars, consider that what you are seeing is not just distant matter, but an integral part of your own origin story. In our ongoing exploration of cosmic mysteries, stardust will undoubtedly continue to be a subject of fascination, acting as the very thread that ties life on our planet to the celestial bodies above. The quest to understand this crucial material compels us to reflect on our position in this immense universe and motivates us to keep searching, questioning, and discovering. The cosmos is teeming with surprises, and the tale of stardust is merely the opening chapter of a much larger story that is still unfolding. Have you ever gazed up at the night sky and thought about the stories hidden behind each of those brilliant points of light? Every star you see has a unique history, and that history is inextricably linked to stardust. This material, which is created and dispersed throughout the life and death of stars, has been a central force in the development of our universe. The real question, then, is how exactly has this stardust shaped the grand narrative of the cosmos? To truly grasp its influence, You must journey back to a much earlier time, when the universe was in its infancy. Picture a cosmos filled with simple gases and primordial dust before the rich variety of elements we see today existed. As the first stars ignited, lived, and ultimately died in cataclysmic explosions called supernovae, they seeded the void with heavier elements forged in their cores. It is through this process of cosmic recycling that stardust became the unifying thread in the history of the universe. But what makes it so fundamentally crucial? Consider dust to be the essential building blocks in a cosmic formula. When stars reach the end of their lives and erupt, the elements they forged are scattered throughout space, forming a kind of foundational material. This cosmic mixture is absolutely vital for the emergence of new stars, planets, and, eventually, life as you know it. Without this stellar debris, the universe would be an unrecognizable and desolate expanse, devoid of the complex structures we see today. This raises a fascinating question. What is the ultimate fate of stardust? As stars expire and eject their elemental contents, this dust embarks on an immense journey through the cosmos. It aggregates, cools, and gathers into dense clouds that ultimately collapse under their own gravitational pull, sparking the birth of new stellar bodies. This perpetual cycle of cosmic demolition and renewal ensures the universe remains in a state of constant transformation. Stardust is not merely a component in the formation of stars and planets. It also plays a decisive role in shaping the very architecture of the universe. When you gaze at images of galaxies, you are witnessing a composite of stars, gas, and dust. This dust can function like a cosmic veil, absorbing light from stars and casting shadows that define the intricate forms of galaxies. Without it, galaxies would lack the distinct shapes and vibrant colors that we can observe. So, how can we be certain that stardust wields such a significant influence? Astronomers employ a variety of methods to observe and analyze these cosmic particles, using telescopes capable of detecting light wavelengths that are invisible to the naked eye. This technology enables them to identify the faint signatures of dust throughout galaxies and map its distribution. It is a process akin to assembling the pieces of a vast cosmic puzzle, allowing scientists to reconstruct the universe's history from these microscopic grains. Many of you may wonder if there is any stardust within our own solar system, and the answer to that is an emphatic yes. Earth is constantly being showered with minuscule particles of stardust from space. These fragments, typically invisible, serve as tiny relics from stars that perished millions of years ago. Every speck of this dust that lands on our world is a tangible reminder of our profound connection to the greater universe. This very same stardust was also instrumental in the development of life here on Earth. The fundamental elements that constitute this cosmic dust, such as carbon and oxygen, are the cornerstones of organic chemistry. Without these elements, which were synthesized inside stars, the existence of life as we understand it would be impossible. This leads to the staggering realization that every living organism on this planet is composed of matter from long-dead stars, a direct lineage that ties us to the vastness of the cosmos. Reflecting on the grand history of the universe, it becomes clear that stardust has been a primary contributor to the formation of the immense gas and dust clouds that gestate new stellar generations. This stellar life cycle represents a continuous journey that molds the fabric of the universe itself. Throughout these stages, dust is repeatedly transformed and redefined, illustrating that the end of one star is merely the prelude to something entirely new. Modern cosmology reveals that stardust is not some inert substance drifting through space, but rather an active participant in the universe's ongoing evolution. As galaxies form and change, This dust becomes an agent of transformation, profoundly influencing how stars and planets come into being. This dynamic interplay serves as a powerful reminder that the cosmos is in a state of perpetual motion, balanced between creation and destruction. Contemplating stardust and its long history inevitably prompts questions about our own collective future. As the universe continues its relentless expansion, what role will this dust assume in the next great epochs of cosmic evolution? Will it persist as the essential ingredient for the creation of new stars and planetary systems? The pursuit of answers to these questions compels us to think about how stardust will continue to be a central character in the unfolding story of the cosmos. In the end, stardust is profoundly more than a mere collection of fine particles. It stands as a testament to the history of the universe, a critical ingredient in the birth of stars, planets, and life itself. It links you to the distant past and encourages you to contemplate your place within an infinite cosmos. So, the next time you find yourself looking up at the night sky, remember that the stars and the dust that surrounds them are all part of a story far grander than our own. Have you ever stopped to consider how something so seemingly small could exert such a massive influence on the entire structure of the universe? The answer is found in the way stardust interacts with matter, energy, and gravity across the boundless expanse of space. To begin, picture the universe as a vast, empty canvas. Each star, galaxy, and particle of stardust acts as a distinct brushstroke, contributing to this cosmic masterpiece. Without this stellar dust, the canvas would remain blank and without color. So, what is the origin of all this dust that seems to permeate every corner of space? It is born from stars which, over the course of their lives and through their spectacular deaths, release this material into their surroundings. This process continuously enriches what we refer to as the interstellar medium. This cosmic material then becomes the very foundation for future creation, a celestial glue holding the universe together. Within these dense and dark dust clouds, molecules coalesce, providing the necessary conditions for gravity to begin forming new star systems. Gravity is the fundamental force that binds the universe together, and the accumulation of stardust is essential to its work. While dust doesn't create gravity, its dense clouds provide concentrated pockets of mass where gravitational forces can take hold and overwhelm other pressures. It is in these stellar nurseries that the material from a long-dead star can be recycled to become the building blocks for new suns and the very planets, like ours, that orbit them. As this cosmic dust gathers, it starts to pull in even more matter, giving rise to dense clouds that ultimately collapse from their own gravitational force to ignite new stars. In this way, dust serves as the primary architect of the cosmos, sculpting the very framework of the universe on the most massive scales. But how is this process affected as the universe continues to grow? Even in the context of an expanding universe, stardust plays a decisive role. As space stretches, this dust becomes more dispersed. Yet this scattering is far from random. It's meticulously guided by the laws of gravity and the complex dynamics of galaxies. By carefully observing these patterns, astronomers can map out how dust is distributed and how it travels through space, which is absolutely essential for us to comprehend cosmic evolution. Did you realize that stardust can also regulate the temperature of the universe? When it clusters together, it has the ability to both absorb and re-radiate light, which in turn alters the cosmic radiation that we detect. Now, let's consider how stardust contributes to the formation of much larger structures, like clusters of galaxies. As this dust collects and thickens, it forms gravitational hubs that attract more material, building the immense cosmic structures we observe today.
This entire mechanism can be compared to the way tiny bubbles in a liquid merge to form larger ones, though on a cosmic scale, gravity is the force stirring the mixture and compelling these structures to combine. So, how have we come to know all of this? The answer is found in the science of astronomical observation. Powerful telescopes and sophisticated space probes have given astronomers the tools to examine stardust across a wide range of wavelengths, allowing us to decipher its composition and chart its distribution. Through this dedicated research, we've come to understand that this dust is far more than a collection of minuscule particles. It is a fundamental ingredient that carries the story of our universe. You can imagine that every single particle of stardust is a tiny volume in a cosmic library, each one chronicling the life of a particular star. By studying these records, scientists can piece together the grand history of the cosmos, which is a narrative not just about stars and galaxies, but about the very evolution of matter itself. Every speck of this dust has undertaken an astonishing journey, starting from its violent creation inside a star's core, and culminating in its slow dispersal across the infinite expanse of space. In the wider field of cosmology, stardust also serves as a crucial tool for investigating dark matter and dark energy. While these phenomena remain largely enigmatic, the behavior of cosmic dust can help scientists better grasp their profound influence on the structure and fate of the universe. With every new piece of information we gather, we move a step closer to solving the deepest puzzles of the cosmos. It's especially fascinating how stardust can directly trigger the formation of entire galaxies. As it clumps into dense clouds, these molecular nurseries can collapse under their own weight, igniting the birth of new stars and eventually new galaxies. This reveals that dust is not merely the aftermath of stellar death, but also the very seed for future generations of stars, operating in a continuous cycle. When you reflect on the role of dust in cosmology, you begin to see the universe as a deeply interconnected system, where every star, galaxy, and particle is inextricably linked. The interactions between these components are what drive the evolution of the cosmos. Therefore, stardust is not just an element of stellar history. It is a fundamental part of our own story, the story of humanity, which occupies one small corner of this immense universe. To conclude this exploration of stardust and its cosmological significance, it's vital to appreciate that every grain of dust, every distant star, and every galaxy is a component of something far greater than itself. Stardust is more than simple matter. It's a profound reminder that we are all woven into the grand tapestry of existence. As we press onward in our exploration of the cosmos, stardust will continue to be a key thread connecting the vast history of the universe with our own presence within it. Since the dawn of humanity, people have looked up at the night sky and felt a powerful bond with the universe. But have you ever wondered what truly occupies the space between those stars, and how stardust has shaped human cultures throughout history? This celestial dust, which might seem inconsequential at a glance, is in fact a critical element that has fueled myths, legends, and philosophical ideas in civilizations all over the world. In the ancient world, the stars were often seen as deities or celestial beings. The Greeks, for instance, imagined that the shimmering dust across the night sky was composed of the souls of their greatest fallen heroes. This idea gave them a profound sense of connection to the divine, as if the cosmos itself were communicating with them through the stellar light. As they gazed into the heavens, they felt they were part of a much larger narrative, with each particle of dust telling its own epic tale. Civilizations in Mesoamerica, including the Maya and the Aztecs, developed their own distinct interpretations of stardust.
In their cosmology, the universe was teeming with gods, and any dust that fell to Earth was treated as a sacred gift. They performed ceremonies honoring their sky deities, believing this celestial dust held sway over their crops and the climate. For them, stardust was not merely a distant cosmic phenomenon, but an active participant in their everyday lives. This perspective began to shift dramatically during the Renaissance, when stardust was re-examined through a new lens. With the rise of modern astronomy, pioneers like Galileo and Kepler started to scientifically investigate the stars and their motions. In this new intellectual climate, stardust transformed into a symbol of knowledge and the relentless human quest for truth. The desire to understand the cosmos surged, and what was once a visual wonder became recognized as an essential component in the creation of the universe. Poetry has also drawn an endless well of inspiration from stardust. Poets throughout the ages have written about the intimate link between cosmic dust and life itself, employing powerful metaphors that speak to the fragility of our existence. In their works, stardust serves as a reminder that all of us are part of an infinite cycle of creation and decay. It suggests that every person, plant, and animal contains particles of this ancient material that has journeyed across time and space to become part of us. Art has been equally captivated by this cosmic fascination. Painters and sculptors have frequently yielded to the allure of the universe's beauty, producing masterful works that aim to capture the grandeur of the stars and the ethereal dust that drifts between them. This artistic expression demonstrates a deep, enduring human need to connect with the cosmos and reflect its magnificent scale and mystery in our own creations. When you see artistic renderings of nebulae and star patterns, it often prompts you to reflect on your own cosmic significance. In this way, cosmic dust serves as a conduit between scientific understanding and creative expression, merging what we know with what we feel. Philosophers have taken this idea a step further, contemplating the very meaning of stardust for our existence and asking whether we are simply animated dust or if our journey holds a higher meaning. These profound inquiries have ignited debates about the essence of life, death, and the ultimate destiny of the universe, transforming dust into a powerful symbol of the human quest for purpose. We also cannot overlook the profound impact that science fiction has had on our view of stardust. Visionary authors like Isaac Asimov and Arthur C. Clarke crafted tales of futures where cosmic dust is integral to space travel and the hunt for life beyond Earth. In these stories, dust becomes the essential medium that links humanity with alien civilizations and far-off galaxies, firing the imagination and positioning it as a symbol of boundless potential. As humanity's understanding of the cosmos has expanded, the concept of stardust has become a subject of study in theology, as well as science. Many spiritual traditions have embraced the idea that we share a common origin, in the same cosmic material, which cultivates a deep sense of unity among all forms of life. This viewpoint encourages you to see yourself as part of a greater whole, connected to everything else by the very particles that compose you, on a shared universal journey. In more recent years, the rise of astrobiology has given stardust even greater importance. Current research indicates that certain compounds found within this dust could be essential for the emergence of life, which has sparked a renewed focus on its role in the search for extraterrestrial organisms. The idea that the dust forming our very biology might share a common cosmic origin compels you to deeply consider the nature of your own existence. Stardust has also carved out a significant niche in education and the popularization of science. As technology has progressed, modern telescopes have yielded discoveries that have captivated millions of people. This expanding pool of knowledge not only stimulates curiosity, but also motivates new generations to gaze at the heavens and contemplate their own place within the vast expanse of the universe. reminding us that learning is a perpetual journey. The dynamic interplay between stardust and human culture serves as a powerful testament to our relentless search for answers to life's most fundamental questions. From ancient folklore to contemporary scientific theories, cosmic dust has acted as a unifying thread woven through the grand narrative of humanity. Every myth, every story, and every scientific breakthrough brings us a little closer to comprehending our role in the immense cosmos. In a world where science and spirituality can often appear to be in conflict, stardust emerges as a powerful emblem of reconciliation. It serves as a reminder that, regardless of our differences, we all spring from a shared origin and are each a part of a much larger spectacle. In our ongoing search for answers, the concept of stardust invites you to continue exploring, to keep dreaming, and to never stop asking questions. Ultimately, stardust is far more than a mere physical substance. It is a profound symbol of the bond between all living things and the universe itself. It reminds you that even though we may seem insignificant against the sheer vastness of the cosmos, our individual stories and experiences hold immense value. So, when you look up at the night sky, you can find not just distant stars, but also your own unique place in the intricate tapestry of existence. Science has devised remarkable methods for unlocking the universe's secrets, one of the most compelling of which is the recreation of cosmic conditions right here in terrestrial laboratories. You might wonder how scientists can possibly simulate the harsh environment of space. The solution lies in a combination of human ingenuity and sophisticated technologies that enable experiments designed to better understand stardust and its unique properties. To achieve this, scientists employ vacuum chambers, which are large, sealed containers engineered to mimic the conditions of outer space. Picture a volume entirely devoid of air, where particles can drift without any resistance. This is how researchers approximate the universal environment. Within this controlled setting, they can investigate how stardust forms and how it behaves when exposed to light and other particles, effectively creating a miniature cosmic laboratory for close observation. One of the most captivating questions driving this research is what actually occurs to stardust while it is adrift in space. In the lab, scientists can experiment with a wide array of substances and conditions to observe how dust grains, which are essentially collections of atoms and molecules, come together. This work helps them understand not only the dust that drifts between stars, but also the material that might exist on other planets, or that is currently coalescing into new star systems. An incredible feature of these experiments is the ability to generate tiny, artificial dust clouds. This is accomplished using advanced cooling methods and lasers, which encourage individual dust particles to clump together into more complex structures. The process closely mirrors what takes place in the cosmos, where gravitational forces and chemical bonds cause dust to aggregate and eventually form planets and stars, offering invaluable insights into the behavior of dust across the universe. This study of stardust also intersects with the captivating field of astrobiology, as scientists work to determine if dust could carry the fundamental building blocks of life. By simulating the chemical reactions that might have transpired on early Earth, they can explore whether stardust could have delivered the necessary ingredients for life to begin. The analysis of molecules that form under these laboratory conditions brings us closer to answering this foundational question about our origins. Even though labs cannot perfectly replicate the cosmos, but only approximate many of its key features. For instance, by cooling and colliding gases, researchers can witness the assembly of complex compounds in a way that mirrors their formation in interstellar clouds, the very birthplaces of stardust. Scientists have also engineered methods to meticulously analyze the chemical makeup of this cosmic dust within a laboratory setting, allowing for a much closer examination of its properties. Through a technique known as spectroscopy, scientists are able to refract the light that dust gives off and identify the various elements it contains. This process is functionally identical to how astronomers decode the light signatures of distant stars and galaxies. By deciphering the composition of stardust, researchers can draw conclusions about the distribution of these elements across the cosmos and their importance in creating new celestial objects.
Laboratory studies are not confined to recreating the birth of cosmic dust. They also extend to investigating its direct effects on Earth's environment. You might wonder what kind of impact stardust can actually have on our atmosphere. Scientists are now beginning to uncover how these spacefaring particles influence our planet's climate patterns and overall health when they enter our skies. The progress of technology now allows scientists to employ computer simulators to forecast and visualize how stardust behaves under a wide range of conditions. You can think of these models as detailed cosmic maps, guiding researchers to a better understanding of dust distribution in galaxies and its influence on the evolution of stars and planetary systems. These simulations enable the study of scenarios that would be utterly impossible to witness directly in space. With every new breakthrough in replicating cosmic environments, we move closer to solving some of the universe's most profound enigmas. What further secrets might stardust be hiding? As our technological capabilities advance, laboratories are poised to become central to unveiling these mysteries, driven by a human curiosity that consistently pushes us toward the unknown. Ultimately, the study of stardust is far more than a simple scientific endeavor. It represents a quest to find our own place within the universe. When we investigate how these particles form and how they impact life, we are simultaneously exploring the nature of our own existence. Stardust, originating as the remnants of dying stars, weaves a thread that connects the cosmos to life on Earth, reminding you that we are all woven into this immense and magnificent story. Although stardust might appear inconsequential on the surface, it actually performs a vital function for our planet and life as we know it. But how is it possible for something so minuscule and seemingly benign to shape Earth's climate and geological activity? To grasp this, you first need to understand the fundamental nature of this cosmic material, which is born from stellar explosions and the demise of gas giants. When a star exhausts its life, it ejects enormous clouds of dust and gas that scatter throughout space. This dust, composed of the universe's most basic building blocks, can journey across incredible distances before eventually settling here on our world. But what exactly occurs when this extraterrestrial material arrives at our doorstep and enters Earth's atmosphere? Upon entering our atmosphere, stardust becomes a key ingredient in the formation of clouds and, by extension, the entire water cycle. Have you ever considered what it takes for a cloud to form? These tiny dust particles serve as a nucleus that allows water vapor to condense around them. Without this cosmic dust, the creation of clouds would be significantly hindered, which could drastically alter the amount of rainfall we receive. Imagine a world where rain was an exceptionally rare event. Without stardust, vast regions of our planet could transform into desolate, barren landscapes. Moreover, this dust carries elements like carbon and oxygen, which are essential for life. As these elements become part of the cloud's makeup, they are delivered to the ground through rain, enriching the soil and fostering the growth of plants in a beautiful, interconnected system. But the reach of stardust extends far beyond water and vegetation, as scientists have found that it can influence the climate in even more intricate ways. For example, depending on the circumstances, these dust particles can either reflect sunlight away from the Earth, causing temporary cooling,
or absorb it, which contributes to warming the atmosphere. How can something so tiny exert such a powerful influence on the global climate? Research indicates that during times of intense volcanic eruptions or extended droughts, stardust can become a significant climate-regulating factor, almost like a massive planetary thermostat, helping to maintain Earth's temperature balance. In a world where human actions have already modified the climate, the role stardust plays becomes an even more fascinating subject for study. The interplay between stardust and the atmosphere can also have an effect on extreme weather phenomena, including major storms and hurricanes. By changing the temperature and humidity levels in the air, stardust effectively becomes a dynamic participant on the world's meteorological stage. Could it be that this minute cosmic dust is a contributing factor in some of the most powerful storms we've ever witnessed? Beyond its climatic influence, stardust also participates in Earth's geological processes. When these particles settle in the oceans, for example, they act as a fertilizer for the water, which stimulates the growth of phytoplankton. These microscopic organisms form the very foundation of the marine food web, making cosmic dust a vital component of ocean life. These microscopic organisms serve as the foundation of the ocean's food chain and are responsible for generating the oxygen essential for life on our world. It turns out that stardust provides nourishment not just for the land, but for our seas as well. Who could have imagined that dust from the cosmos would be so critical for marine existence? Scientists are now starting to grasp that stardust might also be connected to shifts in our climate. As the Earth undergoes changes in its temperature and climate patterns, the natural cycle of this cosmic dust could be disturbed. This disruption might alter how clouds are formed, which in turn would affect the amount of rainfall we experience, carrying enormous consequences for agriculture, water resources, and the survival of countless species, including humanity itself. The investigation of stardust is crucial, not only for comprehending our own planet, but also for uncovering clues about the origins of the universe. Every single particle of dust that settles on Earth serves as a reminder of our deep connection to the cosmos, a link that extends far beyond our daily awareness. Isn't it incredible to consider that with every breath you take, you are inhaling the vestiges of stars that existed millions of years in the past? To summarize, stardust is far more than mere cosmic refuse. Its profound effect on climate, geological processes, and life itself stands as a powerful testament to the intricate interconnectedness of all universal elements. In a time when we often feel detached from the natural world, stardust reminds you that you are a component of something immensely larger, where every tiny piece fulfills a crucial function in the grand tapestry of existence. So the next time you gaze at a cloud, consider the stardust that might have played a role in its creation, and reflect on how this minute material has such a deep and lasting impact on our world. What would you think if I were to tell you that stardust holds a captivating and enigmatic future, one that could shape the very evolution of the universe as you know it? As we explore this future, it's vital to recognize that this cosmic ingredient is more than just the leftovers of deceased stars. Its story is woven into the life cycle of the universe itself. Picture a boundless cosmic workshop where stars are the master artisans and stardust is the medium that gets molded into new creations. Each grain of this dust carries its own unique narrative, and as the universe perpetually expands, this material becomes the fundamental substance for forging new stars and planetary systems. Can you even begin to envision what this cosmic process will entail millions of years from now? Over the course of the next billions of years, stars will persistently be born, go through their life cycles, and eventually die, releasing even more stardust into the void of space. This dust, which is frequently rich in essential elements like carbon, oxygen, and nitrogen will then gather to create new molecular clouds. It's fascinating to contemplate what will unfold when these immense clouds finally condense to form the next generation of stars, each one reflecting the composition of the dust that came before it.
Beyond simply forming stars, however, stardust also has a critical function in the way planets coalesce. The planetary systems that will emerge in the distant future are entirely dependent on the amount and quality of the dust available to them. This raises a compelling question for the ongoing search for life elsewhere. If stardust is the carrier of life's fundamental building blocks, we might just witness the birth of habitable worlds in corners of the universe we can't yet even conceive of. Far into the future, stardust could also act as a crucial indicator of how the universe itself will ultimately behave. As stars perish and this material scatters, it has the potential to influence the very structure of galaxies. Could it be that stardust holds the key to finally comprehending the expansion of the universe? The solution might be hidden within the properties of this dust and its interaction with gravity and dark matter. Furthermore, the history of stardust is not confined merely to the creation of stars and planets. As galaxies continue their evolution, this cosmic dust might be the very agent responsible for building new cosmic structures. Some scientific theories propose that stardust could function as a kind of cosmic cement, helping to bind matter together and shape entirely new galaxies. Just imagine a universe where dust is the primary architect of new cosmic realities. In addition, stardust may exert an influence on phenomena that we are still far from understanding, such as dark energy. While the universe continues to expand, this dust might interact in ways that could help us finally unravel that mystery. Could stardust prove to be a small but essential piece in assembling a grand theory of everything, a single framework that explains all cosmic phenomena? And let's not overlook the immediate connection stardust has to our home planet. As cosmic dust continues to accumulate and transform, the ongoing cycles of star and planet formation could directly impact our own existence. How might this reality alter our perception of life on Earth? It is entirely possible that parts of you are literally composed of stardust, and that our collective future is inextricably linked with the destiny of the stars. Looking ahead, advanced technologies may grant us the ability to study stardust in ways that we can currently only imagine, using more powerful telescopes and probes dispatched to the far reaches of our solar system. Through these future explorations, we are likely to uncover entirely new types of dust and learn about their unique properties. What astonishing revelations does stardust have waiting for us to find? The quest to find life on other planets could also be greatly advanced by the study of stardust. If this cosmic material truly holds the essential ingredients for life, scientists can then focus on detecting signs of it on distant exoplanets. Could stardust ultimately be the map that guides you toward the discovery of new worlds where life, in some form, has managed to take hold? As we venture forward into this new age of cosmic exploration, stardust will undoubtedly remain a subject of intense scientific curiosity. The questions it provokes seem limitless. What other secrets does it conceal? How will it continue to shape the evolution of our own galaxy? Could it be a foundational component in the story of the universe that we have yet to fully appreciate? Ultimately, the future of stardust is as limitless and expansive as the universe itself. As we persist in our exploration and learning, each new finding brings us a step closer to truly understanding our own place within the cosmos. So, the next time you find yourself looking up at the star-filled sky, remember that every particle of stardust has its own story to tell and a future that is still waiting to be discovered. Perhaps at this very moment, in the distant corner of the cosmos, a new star is igniting, fed by the dust of one that came before it, continuing a cycle of ever-increasing complexity.
Stardust, this enchanting material drifting through the void, is often romanticized in culture as something mystical. But do you truly grasp what it is and how profoundly it influences your life? Let's work together to clear up some prevalent myths about this fascinating cosmic ingredient.
A common misunderstanding is that stardust is nothing more than inconsequential cosmic debris, when in fact it serves as the foundational material for everything we see around us. When you think of dust in space, you might envision something like airborne particles, but each grain is a vessel of cosmic history. These particles are the legacy of stars that have lived and died, carrying elements that have journeyed for billions of years to help form planets, new stars, and life itself. Another point of concern is whether stardust could be hazardous to your health. The reality is that the cosmic dust reaching Earth is almost entirely harmless, even if the idea of being showered by extraterrestrial particles seems strange. Most of this material simply burns up in our atmosphere, posing no significant threat, so you can certainly breathe easier knowing this. People frequently ask if stardust is something you can actually see, and the answer is more layered than you might expect. From our vantage point on Earth, individual particles are far too small to be seen, but you can observe vast clouds of this dust within nebulae. These cosmic clouds are so incredibly dense that they can completely obscure the light of the stars that lie behind them, creating a breathtaking celestial spectacle. It's a common misconception that stardust is a phenomenon exclusive to faraway galaxies, but it is abundant right here in our own Milky Way. This cosmic material is all around us, even on Earth, connecting you directly to the greater universe every time you gaze up at the night sky. In a similar vein, while massive stellar explosions known as supernovae are a significant source of this dust, they are not the only one. Stars at many different stages of life, including red giants like our sun will one day become, also release matter that evolves into stardust. The elements that compose stardust are precisely the same ones that form our planet and everything on it, from carbon and oxygen to iron. This leads to the remarkable and scientifically supported conclusion that we are all, quite literally, made of stardust, a fact that gives profound context to our existence. And what's more, the complex organic compounds found within this cosmic dust are considered the potential building blocks from which life can emerge. Contrary to any notion that stardust is static, it is an incredibly dynamic substance, constantly moving through space in great streams. This perpetual motion and interaction of gas and dust fuels an endless cycle of cosmic creation and destruction, which is fundamental to the universe's evolution. Scientists don't just study this with telescopes. They also use advanced laboratories and simulations to recreate cosmic environments, deepening our knowledge of stardust's behavior and composition. It is also a myth that stardust has no tangible effect on our planet. This material can actually influence our climate by playing a role in the formation of clouds and precipitation. Furthermore, as this dust settles on Earth, it can enrich the soil with vital nutrients, demonstrating that it is not just a passive background element, but an active participant in the life of our world. Ultimately, a deeper appreciation for stardust helps you better understand your own place within the cosmos, connecting you to the stars and the grand history of creation. This material has long sparked the creativity of artists and writers, appearing in everything from poetry to science fiction, as a reflection of our innate curiosity about our origins. In these stories, stardust often becomes a potent metaphor, linking the vastness of space with the intricacies of the human experience. When you consider how these narratives use stardust as the origin point of everything, you begin to see why it holds such power. Imagine that every star you see twinkling in the sky is a cosmic heart,
and the dust swirling around it is the very lifeblood that nourishes its existence. This powerful image captures how a simple speck of dust can hold the story of the universe and our own search for meaning within it. This poetic vision implies that you and I are participants in an endless cycle of creation and destruction. One of the most memorable narratives to feature Stardust is Michael Ende's The Never-Ending Story, where dust is intertwined with fantasy and the birth of worlds. In that tale, every particle signifies a new life waiting for its moment, suggesting that dust is not merely matter, but pure potential. This concept leads you to ask, could it be that what we perceive as reality is nothing more than stardust in perpetual transformation? The Star Wars saga also explores the Stardust theme, as characters frequently journey through the immense voids of space, where cosmic dust is a constant presence. Far from being just a visual backdrop, this dust comes to symbolize the hero's personal journeys. The lesson you can take from these intergalactic sagas is perhaps about the quest for identity and purpose, themes that connect profoundly with the human condition itself. In the film Interstellar, stardust is integral to the story. As the characters navigate wormholes and manipulate time, they learn that dust is not only a physical element, but is also tied to the concepts of love and the bonds between people. At its heart, maybe stardust truly signifies the interconnectedness of all existence, an idea that invites you to contemplate how deeply each of us is woven into the fabric of the universe. Science fiction writers often employ stardust as a potent symbol of mystery. In Frank Herbert's Dune, the dust of the planet Arrakis is absolutely essential for the survival of its civilization, eventually becoming the most precious spice in the cosmos and a symbol of power and change. This makes you consider how we assign value to resources in our own world, where dust can represent either a vital asset or a significant hindrance, all depending on our perspective and actions. Throughout literature and film, stardust frequently serves as a trigger for extraordinary events. Consider how, in the Hunger Games, dust and ash are used to symbolize oppression and the fight for liberty. This depiction of dust as a memento of all that has been lost strikes a chord with many real-world situations, urging you to think about how the remnants of our own history can define the path of our future. Stories centered on intergalactic journeys also introduce the notion of stardust as a potential conduit for communication. In Carl Sagan's Contact, cosmic dust serves as the very medium for messages sent by advanced alien civilizations. This concept presents you with a fascinating question. Are you actively listening to the universe's whispers around you, or are you too preoccupied with your own affairs to perceive these subtle signals? Science fiction does more than just entertain. It confronts you with serious ethical and moral dilemmas regarding your relationship with the cosmos. In Blade Runner, for instance, dust acts as a poignant reminder of life's fragility and the ongoing search for what it means to be human. This existential struggle compels you to wonder, are we simply dust in the wind? Or does our existence hold a deeper significance? Within the world of animation, movies like WALL-E delve into the consequences of dust and pollution on our planet. The portrayal of dust as a symbol of carelessness and desertion forces you to confront your own responsibilities to Earth. It raises the question of how you can ensure the legacy you leave behind is one of renewal and not one of devastation. Stardust has also made its mark in the realms of poetry and music, inspiring countless people with the idea that we are all composed of cosmic matter. This notion has seeped into popular culture, influencing everything from songs celebrating our celestial origins to poems that capture the beauty of a fleeting existence. This fusion of science and art serves as a reminder that, despite your fragility, you are also part of something truly extraordinary. The future of stardust in science fiction appears incredibly promising. As our technology progresses and we venture further into space, our stories will naturally evolve. Dust will likely become an even greater symbol of discovery and awe, encouraging you to imagine new worlds and possibilities. Perhaps you will soon encounter narratives about civilizations that have mastered living in harmony with the very dust of their planets. Ultimately, science fiction provides a mirror for you to examine your connection to the universe. Within these narratives, stardust emerges as a powerful metaphor for the human search for meaning and belonging. It shows you that even though you are a minuscule speck in the vastness of space, every individual possesses the capacity to shine and make an impact on the cosmos. When all is said and done, stardust reminds you that you belong to something far larger than yourself. It beckons you to challenge your assumptions, test your boundaries, and forge a deeper connection with the universe that surrounds you. As you continue to look up at the stars, perhaps the dust you see is not just the aftermath of creation, but the very beginning of new tales waiting to unfold. Stardust is more than a simple gathering of particles. It's a testament to the profound interconnectedness of everything in the universe. But what actual role does this cosmic dust play in your day-to-day life? To grasp the true magnitude of its influence, you have to look back and value every step you have taken on this shared cosmic voyage. Through this exploration, you have come to understand that stardust is the product of perpetual cycles. Stars are born, they live their lives, and they eventually die. And through each of these phases, they bestow upon us the fundamental elements that constitute everything you know. Did you realize that, in a very real sense, every one of us is made of stardust? When you gaze at the night sky, you are not just seeing distant points of light, but are witnessing a direct link to the entire history of the universe. Every star that glimmers in the darkness is a reminder of the cosmic dance that brought your world into being. The importance of stardust goes far beyond its origins. This dust, created from the death of stars, becomes the raw material for new suns, new planets, and, ultimately, new life. It is as if the universe is in a constant state of recycling its own components, orchestrating a symphony of elements that weave together in an eternal cycle. It's remarkable to think how something so seemingly small can have such a transformative effect on the immensity of space, and even more astonishing, to realize that every person on Earth carries elements that were once part of a faraway star. Every single breath you draw, each water molecule, and all the atoms comprising your body originate from the stars. This profound truth doesn't just link you to the cosmos. It prompts a deep contemplation of your very existence. It's a truly incredible thought, isn't it? That when you gaze upward into the night, you are essentially looking at the source of your own physical being. This intimate connection to stardust also fuels the quest for life on other worlds. Researchers are now starting to decipher the secrets concealed within this cosmic dust, searching for any sign that life could emerge elsewhere. Every microscopic particle drifting through the immense void might contain the very answer to how life-sustaining environments come to be, raising the question of what secrets it will unveil on distant planets. Exploring this subject further, it's impossible to overlook the immense impact stardust has had on the entire history of the universe. It has been a critical ingredient in shaping the cosmos we observe today, from its function in birthing entire galaxies to its influence on the development of planetary systems. The very essence of stardust permeates every region of space, acting as a quiet observer of cosmic evolution. The field of cosmology, which investigates the universe's origins and development, is greatly enhanced by the study of stardust. Beyond its role in the creation of stars and planets, this cosmic dust offers vital clues about the expansion of the universe itself. You can think of it as a celestial map that leads us back through time, uncovering long-held secrets woven into the very fabric of space-time. Shifting to a cultural perspective, the idea of stardust has been a powerful source of inspiration for countless generations. Its significance has been reimagined in numerous forms, from the tales of ancient mythology to the narratives of contemporary science fiction. This concept has profoundly shaped our worldview, as the bond between humanity and the cosmos provides a limitless well of inspiration that encourages us to question and explore. It's crucial to see stardust as more than a mere subject of scientific inquiry. It is a profound call to introspection. It serves as a constant reminder that you are composed of the very same elements as the stars, and that every individual has a part to play in this immense cosmos. This realization beautifully underscores both our humility and our importance in the grand scheme of things. The next time you find yourself looking up at the night sky, take a moment to consider the incredible voyage those distant points of light have completed. Contemplate the journey of the stardust that has drifted across eons and galaxies, and recognize how its story is woven directly into your own. In this universal epic, stardust is the unifying element that links all of history, reminding you that you belong to something far larger than yourself. In concluding, we can appreciate the true significance of stardust to our comprehension of the cosmos. It is more than just a basic building block of matter. It stands as a potent symbol of our interconnectedness and the unending flow of existence. Every star, planet, and living creature is a resonance of this original stardust, a testament to our shared participation in this grand cosmic journey. When you are enveloped by the night, know that you are never truly alone. The universe is there with you, and within each speck of stardust lies a story yet to be discovered.